Hello and welcome to the summary video of the Geothermal Emission Control Project, also commonly known as GECO. My name is Amel Barish. I am the Communication Officer, Coordination Support Team Member, and responsible of the business case of GECO. GECO is a Horizon 2020 project that aims to develop clean, safe, and cost-efficient geothermal energy. More concretely, the project aims to tackle mineral carbon capture, sequestration, and utilization within 4 different geological contexts. It is a consortium of 18 partners that came together with an 18 million euros budget at hand to bring geothermal energy to the next levels of excellence.
We are optimizing solutions to make them less energy intensive with the aim of creating cleaner geothermal power plants with less emissions, but without putting too much burden on their operation. That's perhaps the main thing. We are also looking into specific aspects of doing very intensive corrosion monitoring for preventive, to prevent maintenance and disruptions of the operations. And that is indeed very important to make geothermal more cost competitive.
Carbfix has 2 sites in the GECO project. The Hellisheiði site, where we have captured and injected CO2 from the Hellisheiði power plant since 2014, and the Nesjavellir site. Both sites are associated to the same volcano, the Hengill volcano, so we are utilizing geothermal power on both sides of the mountain, and now we will start injecting CO2 from these power plants on both sides of the Hengill volcano. We are building on the Carbfix technology, which was developed at one of our sites in Hellisheiði, where we have been injecting CO2 from the Hellisheiði power plant since 2014. There we were exploring the possibilities of utilizing the CO2 from the geothermal plant. And then we have also moved to a second site on the other side of the Hellisheiði site. There we are optimizing the technology that we have been developing in Hellisheiði and will start capturing CO2 from this second power plant in June and inject it to a nearby field. So that's our main goal of Work Package 5.
In Kızıldere section of Turkey, there is a considerable amount of CO2 emissions into the air. And we want to prevent that by using this technology, GECO technology, this project, to reduce the emissions in Kızıldere site.
Education and knowledge were a fundamental part of the GECO project. GECO supported several PhD theses as part of the project's work. We also hosted a summer school in Castelnuovo, Italy, to train and inspire the next generation of geothermal CCS and CCSU professionals. Part of our outreach activities as well was to host webinars where GECO experts shared the knowledge about all the methods and results used and produced respectively within the lifetime of the project.
Our site is a test site in sedimentary environment, so in a low temperature environment. We know that sedimentary rocks are the most abundant type of rocks on the Earth's surface, covering about 75%. So we are testing the CO2 injection there. Moreover, since we are not directly linked to a geothermal power plant, we are building a fluid reactor where we can create artificially several brines, geothermal brines, and bring them to temperature and pressure of reservoir rocks.
In Hellisheiði, we have been looking into corrosion monitoring, isotope monitoring, and looking into options of purifying the CO2 that is being emitted from the power plant. In Nesjavellir, we are developing our capture technology, where we are capturing the gases, non-condensable gases, CO2 and H2S, and injecting it. There, the fate of the CO2 and H2S is monitored in the subsurface. And then in Hveragerði, we are working with our partners of Storency and Graciela to bring a closed-loop unit, which will be tested there. So from a discharging well and into a re-injection well for a zero-emission operation.
Geothermal emission control systems are both technically and economically viable. They can be integrated in other geothermal power plants of similar contexts. From a utilization perspective, byproducts of geothermal emissions are also relevant to the raw material sector, specifically the construction industry. This opens the door to circularity perspectives, but also to cross-industries sustainable practices.
The corrosion monitoring system designed in GECO presents the main advantage of assisting the geothermal plants to optimize the maintenance operations in their facilities, because this system can detect the corrosion damage in the installations and prevent serious future failures in the plant.
Life cycle assessments are really important in the industry because it allows them to know their CO2 emissions into the planet and how to reduce them.
The main objective of GECO is to produce electricity and heat from geothermal power plants with less emissions, either by taking these emissions and injecting them into the ground and mineralize them, or to create value from these emissions if that is suitable at any given power plant.
After 4 years and a half, a pandemic in between, and different challenges natural to large and innovative projects such as GECO, we are extremely proud of bringing this project successfully to completion and setting a solid base for CCSU development in the geothermal energy sector. We would like to thank all our collaborators and partners for their openness, resilience, and especially high collaborative spirit. We look forward to seeing GECO systems thrive in the geothermal energy sector, and with this supporting the global efforts in reaching the net zero. Thank you for watching.